All right, thank you for coming to Harmonization and Schema Transformation of Existing Spatial Data. Today we've got quite a bit to show you. My name is Dean Hintz. I'm from Safe Software from Vancouver, Canada. And I have with me Soren Ducke from Conterra from Germany. And Safe and Conterra work together on a lot of things, and Inspire is one of them. And today we're going to show you, in terms of actually implementing Inspire, how do we go about integrating the diverse range of source data that you might have to deal with. Because the whole Inspire infrastructure is very powerful in terms of being able to share data, but in order for that infrastructure to work, you have to load it first, and that's really the big challenge. So I'm going to talk first a bit about FME tools for supporting Inspire, some of the basic harmonization principles, what are the key challenges that we have to overcome, and some examples of FME tools that help you overcome those challenges. And then Soren's going to go through the Inspire Solution Pack for FME, and it's an extension to FME that Conterra has developed that makes that effort a lot easier, because they've done the heavy lifting when it comes to both architecting the FME models and also interpreting the Inspire specifications. And then I'll wrap up with a few words about reading and consuming Inspire, because once we go to all this work of creating and populating the Inspire infrastructure, well, what use is it if we can't actually consume it? So we'll talk a bit about that. So just a few words about FME and Inspire, and then I'll also give you a brief overview of FME. Maybe before I get into that, a show of hands for those of you who know what FME is or have used FME. Okay, so about half of you. And I'm not so much here just to promote FME, but to talk about ETL. So, for example, Safe Software does the ETL or the Data Interoperability Extension for ArcGIS. And so that, in the context of ArcGIS, that's called an ETL tool. And there are other software tools out there that do ETL. ETL stands for Extract, Transform, and Load. So some of these concepts could also apply to those other tools. In the context of FME and Inspire, our goal is to provide you with all the tools you need to do the data harmonization and load the Inspire infrastructure. And then we have a number of partners that have applied FME technology to develop solutions either for their specific countries or more general solutions like Conterra's, which can be applied in any context. And Soren will get into the detail of that later. Just a few words about Safe Software. We're from Vancouver, as I said, from Canada, close to 100 employees, and we have many certified professionals around the world, many partners, 50-plus partners and system integrators in 35 countries. And people are probably more than 120 countries now, people are using FME. So it's certainly a globally used product. So just a few intro slides about FME for those of you who maybe are not as familiar with it. There's three main concepts, and this does relate, I'll relate this directly to Inspire in a couple minutes, and you'll see some common threads. FME is centralized, semantic, and transformational. What does that mean? Well, there are many ways that you could do data harmonization. Let's say the simple CAD to GIS problem. You could write a translator for every CAD format to every GIS format. So you could have DWG to shape and MicroStation to map info tab, etc., etc. And then you have a whole library of transformation routines. And those you could call those bilateral. FME has a different philosophy. It's centralized, so all you have to do is define the transformation from any given data model or format to FME, and then from FME to any destination. And then you can do the data modeling independent of format internally within FME. So that's what we mean by centralized. Semantic, that means that we preserve the meaning. There's a lot of tools out there. Let's say you want to publish something to KML. A lot of tools will just take whatever data you have, let's say a shapefile, publish it to KML, and you just get this kind of white blob of data sitting on the Earth's surface, but there's no styling, there's no information or attribution. That's of limited use, especially when we talk about Inspire. We really need all the richness of any source data model that you have, because you need to be able to map that to the Inspire schema. So it's very critical that the tool that you have to do the data integration supports as much of the source data model as possible. I know in the abstract we mentioned a little bit about CAD, so I want to make sure I use some CAD examples. I know a lot of people, those of us who work in GIS, sometimes think everybody uses GIS, but a lot of times the source data might be a non-spatial table, might be an Excel spreadsheet, the source data might be AutoCAD or MicroStation. And in the case of CAD data, a lot of the semantic information is contained in the styling of how that data looks, the color or the line pattern. And that ultimately needs to be extracted and somehow mapped to the Inspire schema. When we talk about transformational, in a minute I'll show a few examples of that. Transformational talks about transforming both the geometry and the attributes. So whatever, in most cases, the output we want does not have the same data model as the input. And, well, why are we getting into transformation? A lot of people know about FME in terms of format translation, but what we found when we go from one format to another, underneath the reading and writing of data, there's also a data model change. So the CAD world sees the world as drawings with dimensions and line patterns. The GIS world is very much relational or record-oriented features with geometry and attributes. So it's a very different fundamental data structure. Just like when we go from CAD or GIS data to Inspire, it's a very different schema. And so that kind of transformation is fundamental. So in terms of the type of data formats that you can transform with FME, CAD, GIS I mentioned. There's also, we can consume web formats, and later on we'll talk about how can you layer Inspire services. So you might want to take a number of Inspire services and combine them to make a new service. So with FME you can read and publish web formats as well. And we support things like LiDAR, 3D, raster, etc. So these are all the different families of formats, spatial databases, XML, of course. And I'll have a few more slides later on about XML when we talk about consuming Inspire. So we support about 300 odd formats, and really any kind of spatial data out there. If there's something that we can't consume and you need it for your Inspire project, come let us know, and we can put it in our to-do list. So we read pretty much all spatial data out there, except there's maybe some internal formats that are only used inside one application. We may or may not support that. And then we support a lot of non-spatial formats. So ODBC, Oracle, SQL Server, non-spatial, you can consume that data as well. And that's also part of the transformation process. In many cases, you have to read non-spatial data and then georeference it. So geocode it, create points, and load a database. So this is just what does the transformation desktop look like. Our key interface is what we call Workbench. And on the left side here, we have our data sources. And then in the middle, we have what we call transformers, which do the transformation of the data. And on the right, we have the destination. And So in this case, I'm reading a CSV file. I'm taking XY coordinates, generating point locations, and then based on the value of one of the fields, I'm filtering the data and loading the destination database. And we'll get back to this in a minute. So these workspaces can be as simple or as complex as you need to make them. It might be as simple as having a source format and a destination format, or there may be quite a few transformation steps. And as you'll see with some of Soren's examples, that can get fairly complex if the data model and the transformation is a complex one, as it is in Inspire. And that's why having the Inspire Solution Pack is very powerful, because they've done a lot of that work for you. So specifically focusing now on Inspire, how do we apply an ETL tool like FME to Inspire? As I said, we have format translation, schema mapping. There's also things like data validation. So if we're going to go to all this work of populating Inspire data sets, why not validate the data along the way? What's the point of loading erroneous or bad data? So even though you may be working on an Inspire project, you can get a lot of value out of that project if you do work that you have to do anyway. And so if you can do validation, maybe you're submitting an Inspire data set to Brussels, but you can generate a validation report saying which records need to be updated locally. And as I mentioned, integration with other web services. I don't know if we'll have time to get into it, but we can also provide metadata support. And specifically related to Inspire, I could do a whole other session just on XML, because it's a fairly in-depth topic. So FME gives you, really it gives you the ability to publish to GML and XML and consume XML without having to be an XML programmer. So with writing GML, we have a tool called Templater, which you have a template of the XML record structure, and then you can feed in FME records into that, and then consuming, we can read virtually any XML or GML that's out there, whether it's a file-based source or it's on the web. And I have some examples of that in a minute. Now back to Inspire. Again, you can see the common thread here. What are one of the driving themes for Inspire? The whole point of it is to have a common data model to promote data harmonization. And that, you can see how that parallels how FME is set up. We set everything up to be centralized semantic transformation. So FME is an ideal fit for supporting Inspire. Also, open standards are critical. And with FME, we make supporting open standards one of our top priorities. And so when an open standard comes out, that's you know, an ISO standard or OGC standard, we make a lot of effort to make sure that our tools support that. So this is the whole challenge. How do you go from what you have to what you want? And I'm not saying your data necessarily looks like the picture on the left. That looks more like my office maybe. But how do we take all of our source data and then organize it in the Inspire structure? So I think I've covered that already. So I mentioned a bit, we've already talked about translation. A few more words about transformation. As I said, we can go from non-spatial to spatial. We can do geometry extraction. So take spatial data and then extract it as GML, for example. We can transform the different representations, so CAD to GIS. We can do spatial reference transformation, so between coordinate systems. and also building complex geometry. So Inspire, in some cases, you need to have, for a road, you might need an area representation and a centerline representation. So in GML, you can store multiple geometries per object. Most GIS or CAD only have one geometry per feature. So with FME, you can build that. And in many cases, you need to do interpolation or generalization. So if you have regional data sets and you need to aggregate them to a national level and then submit that, you may have very high precision, which makes the data sets very large, and you could generalize and reduce the volume of the data. This also becomes very important when you generate things like web services. And WFS is not really known to be a high-performance data distribution standard. So you might need to generalize your data to reduce the volume of vertices before you publish it as a web service. Well, this is just an example of geometric transformation, something like intersection. And then I'll focus now mostly on schema transformation before I hand it over to Soren. So for schema transformation, this is really one of the key concepts I'll probably talk about in depth. Later on, I'll talk about XML. Right now, I'll focus on schema transformation. What do we mean by that? What is schema to begin with? Well, schema is just another a fancy word for data structure. And you might have a very simple source data structure, and I'll show you a good example of this in a minute. And it may simply be XY location and a place name. The destination in the case of Inspire is actually quite complex because Inspire wants to have a very rich data model that will allow for exchange of data throughout Europe. And so it was designed to kind of capture every situation. For example, a place name, it doesn't just have a name. It has a spelling, and the spelling can be in multiple languages. So now we have a list of names for that location. And then we have to identify which character set is used, etc. So the destination, there's obviously some schema transformation that needs to happen. Now when we do schema mapping, what we're talking about, first of all, we can map the feature type name. Now what do I mean by feature type? You could also call that the layer name or the feature class. So the layer name might change. The source might be roads, the destination might be street. Then the attribute names might change. So instead of street name, you have route name or something like that. So the names can change. And then there's code lists. So you might have highway, boulevard, road, and then in the destination might be a code list. So you have 101, 102, 103, or the reverse. And then you get into conditional value mapping, and I'll show that's easier to show by example. So in terms of what this looks like in Workbench, again, you can think of Workbench a little bit like a data flow diagram. So it shows what's the data that you start with, what are the transformation steps, and then what is the data that you want at the end. And this is the same example here, just reading a CSV file and splitting up by road type to the destination. So that's a type of feature type mapping. And here is just doing the attribute mapping so that primary direction just becomes direction, road category becomes category. So that's as simple as it can get. Or you can use a transformer here and actually do the mapping in a drop list so that if you have hundreds of names, it might be easier to use this interface. There's also an import option at the bottom where you can import that, let's say, from a spreadsheet. Now, Soren will show you some examples later on of some transformers that they have developed that customize this type of feature type mapping and attribute mapping are customized specifically for Inspire. And then you get context-sensitive help. But these are the building blocks that you get when you get FME. Now this is value mapping, so here you can see we're mapping the code from a code list number 1 means paved, code list 2 gravel. And you might say, oh, well, this looks like a lot of work to set up. And that's true. This is the whole point of this process, is that you go to the work of modeling the data flow, but then once you've modeled it once, it's fully automatable. You can call it from a command line, or you can set it up as a server process, and then, or there's just a data update. You can just run it from the desktop, but you just hit one button, and it does all of these processes. So it's a different approach to manipulating spatial data, as opposed to, let's say, a typical GIS environment where you have a menu and you interact with the data, and it's a nice interface, but it's all manual. This is all, the whole focus of this is to automate. Now I'll spend a little bit more time on this, and then I'll run the demo which shows how it works. This is an Inspire Geographic Names demo. And what we have is a spreadsheet which defines all the relationships. And is this on? Okay. With FME, there's always more than one way to do things. Sometimes people say, oh, why did you show it this way? And then somebody else showed me how to do something a different way. Well, with FME, it's almost like a Lego tool set where you can piece it together how you want, and so depending on the customer requirement, you may end up implementing it differently. Now, if you have a very simple schema mapping problem, maybe you use those individual transformers, or you want to have different the problem spread across different parts of a workspace. But another approach is you can have a schema mapping table where you define all of the mapping relationships in a spreadsheet, and then one transformer, see the schema mapper up the top, invokes all these transformations at once. So in this spreadsheet tab, where it says schema.fieldnames, we're mapping geographic names. So there's a source shape file with text, type, and type location. And we map text to name, geographic name, native value. And we map type to lowercase type and type loc to type local. And the nice thing about this approach is that you can actually give the spreadsheet to the domain experts. They can fill in the schema mapping, and they don't have to learn a new tool. They just enter the values, and the software figures it out. And this is what I mentioned earlier is the conditional mapping. So you can get a little more sophisticated. You can say, if the country name is Italy, create a field called name geographic name and set it to Italian. And if the country name is Austrian, create a field called a geographic name language and set it to German. So you can't just add N on the end. It would work, okay, Italian, it's Italy, they speak Italian, and Croatia, they speak Croatian, but in Austria, they don't speak Austrian. Well, maybe some other people might consider Austrian the language instead of German. But so that's one example. And I'll just mention that in the attribute mapping, you could also do feature type mapping. So you could have one column where the source column is the source table name, and the destination side is the destination table name. So just different ways of doing schema mapping. So this is what the workspace looks like. And it's probably better if I just run it live. So let me just run this live. Now this might look a little bit complicated for those of you new to FME, so I'll kind of step through it slowly. So we have these at the I'm running FME 2013, which is probably not a good idea when you're doing demos, so I'll stick with 2012. Okay, because my bookmarks weren't showing up. So one way we organize workspaces is we can create these, it's just a grouping of transformers, and it's a nice way to organize things at a high level. And so you can see here, I've numbered everything. So those of you who are FME users, that's a nice way to set up your bookmarks, is if you prefix them with the number, then it orders the operation. So really what this whole workspace is a good example of is the whole ETL process. The first step in terms of data assembly, so under 1, reading the source data, selecting the areas of interest, that's all part of the E part of the ETL, the data extraction. And then under 2, we have the transformation steps. So the schema mapping, basic schema transformation and schema mapping with the spreadsheets, that's under 2. And then under 3, we have the GML generation. So you could say that's the publishing or the loading side of the whole harmonization process. So generating the required Inspire fields and then building the XML. And Soren will also show you some good examples of that in a minute using the Inspire Solution Pack. So let's just zoom into each of these tabs individually. So in terms of assembling the source data, we start off with a couple of shape files, and as I said, often the source data structures are a bit simpler than what we need for the destination Inspire. And really here we're just interested in, this is the country, so we just need the country name. This is a UN Gazetteer data set, which is freely available for the whole globe, and so I just chose that as a good source. And you can see is just text is the place name. So really it's just an XY location, text, and a type. And then we get some additional fields from the administrative areas. So there's a bunch of additional information there about the administrative region, country name, etc. Now what do we do with this? First of all, we don't need the whole world, so we just choose the countries that we're interested in. In this case, this demo, I'm using data for Italy, Austria, and Croatia. Now, this tester transformer can also be used for things like validation. So I could be checking not just filtering on the value of a name, but I could be checking value ranges of an integer floating point value. Then we do a spatial clip. So we clip out just the areas so we're actually using the geometry of those countries to clip the global gazetteer data set just for the points that fall within those boundaries. And then this is a key tool. Often, let's say for example, the source for your geometry data may not have all the attribute data that you need. So in FME we provide many ways of doing joins to take an ID or an XY location and grab all of the attributes maybe from a non-spatial data source that relate to it. In this case, the point on area overlay, what it does is we have a bunch of information on the points. Actually, it's the reverse. In this case, we have administrative areas, and there's a lot of information there we want to transfer to the point. And we can do that either way. And then we also have transformer, for example, a joiner, which lets you use an ID and get attributes from an associated database. Then here's the attribute copier you saw earlier in the slide. And there's the import function. So if you have a list of 50 different attributes, you can just import them. You don't have to type it. And here's the value mapper. So that's one approach. The other approach is the schema mapper approach, and that is essentially a wizard that lets you define. Here are several different types of mappings at once. So mapping attributes, mapping, that conditional value mapping or mapping feature type names. And before I run it, I'll just show you what the spreadsheet looks like. So here, all in one spreadsheet, I've defined the mappings of the source field name to the destination. And here is the conditional mapping. So if country name is Austria, create a field called geographic name language and set the value to be German. So I know it's a little bit technical, but just showing you so that you've kind of seen an example of how that works. And I won't spend too much time on the GML generation because Soren will show you a solution that does all of that in the context of ArcGIS for Inspire. This is just to show you that FME can generate GML, but if you would have to basically be an Inspire expert to design all the GML output, and using the Inspire solution pack, they've done all that work ahead of time. So this is just showing only one feature type. This is not a complete solution. It's just a single feature type output. So we do some ID generation here and coordinate extraction because we need the coordinate system. And then ultimately what we have to do here is we have a template for the XML document, the header and the footer of the XML document, and then we have to insert the XML features in the middle. And then this is essentially modeling the named place record. And if this looks a bit technical, you could also think, well, if you're using the Inspire Solution Pack to generate the GML and you don't have to worry about this, this could also be useful if you need to generate a metadata record, which is in XML. So you can put the ISO 19115 schema in here, a sample record, and then the key thing is the FME fields. If I want to put in geographic name language in here, all I have to do is double-click on go to the location where the language tag is, you can see on the screen there in the middle, and I double-click on geographic name language, and it inserts this function call, which inserts the value of the FME field at that point in the XML structure. So while this might look complicated, all you really need to do is paste in a sample XML record and then insert the field names from FME where you want to merge the feature type attributes in. So let me go ahead and run this. Well, the last step is validation. So this validates against the Inspire geographic name schema from the JRC. So I'll go ahead and run it. So you can see the various source countries here, Italy and Austria, etc. This is the source data, the gazetteer data, so it's a very simple shapefile where you can see those text type field names, XY. And here is the destination schema, essentially the Inspire schema. So name, geographic name, language, Italian, named place, there's a code for the namespace which is required to comply with the schema, and then the actual place name is Perugia. Or if we go over to Austria, we can pick a place there. I don't know if I can pronounce it, Murtzerschlag, and yeah, German. So that's basically a very simple example that demonstrates the concept of ETL applied to an Inspire use case. So we did the extraction, which was essentially reading the source formats here, in this case shapefile, the transformation, which was predominantly a schema transformation. We could have also done reprojection, let's say from an ED50 to ETRF89, and then finally the loading, which is, in this case, is GML generation. In the case of the Inspire solution pack, the loading process would be loading the ArcGIS for Inspire geodatabase. So just a couple of wrap-up slides before I hand it over. So as I mentioned, you could do a lot of validation along the way. You could make sure that IDs are unique. What would happen is if you don't make unique IDs and you try to generate GML, then it will fail on the schema validation. But what's the point of generating trying to generate bad GML if you can detect that problem up front? We can also do things like evaluate topology or geometric integrity. So is it really a polygon? If it doesn't close, it won't be a polygon. So again, if you try to load that into a geodatabase, you're going to get an error. But with FME, you can pre-filter it and maybe create a list, a report, maybe even a CSV file, listing the IDs and the problem from a bad record. Data gaps, bounds, you might have out-of-bounds data or data that wasn't transformed correctly. And in terms of publication, really that's when we talk about publishing Inspire services. And after Soren talks, I'll show you one or two quick examples of how do we consume multiple Inspire services and generate a new customized service associated with maybe a client that doesn't understand OGC standards. I think I'll probably leave it there. And,
okay.
Yeah.
Okay, thanks, Dean.
Yeah. So Soren will tell us now about the Inspire Solution Pack.
That's very good. Okay, yes, I'm going to talk about the Inspire Solution Pack. So like Dean already said, this is an extension of FME. So the reason to build this extension was that very often the starting point when you begin with the Inspire schema transformation is that there's not necessarily the same person that has the expertise with the Inspire specification and also the internal or the source data models that you want to map. And also maybe might not be the same person that is an FME expert. So one of our goals when creating the Inspire Solution Pack for FME was to make it more easy for these persons to yes, share their knowledge and to work together. So the Inspire Solution Pack comes in here in the middle so that these people have it easier to share their information and to work together. So, like Dean already said, the Inspire Solution Pack doesn't aim to directly write XML, but we use a geodatabase model that is provided by Esri. So our ETL process doesn't aim to write GML, but we fill the geodatabase model. So usually the situation is that you use the source data, then it will be transformed into this geodatabase, and all the services and the XML, the view services, and everything that Inspire requires will be provided by ArcGIS for Inspire. Before I go more into detail of the ISP and show some examples, I would just have a few words on this data model. So the thing that you probably all know is the UML models from the data specifications, and one of the implementations of these application schemas is the GML application schemas that are used by the Inspire data download services. And the geodatabase that we use is also automatically created from these UML schemas. And yeah, it's an implementation of the same model. So whenever there's a change in the UML model, it will also be integrated in the geodatabase that is used by ArcGIS for Inspire, and that we also use as a target model for our product, the Inspire Solution Pack. So yeah, this is just some numbers about the geodatabase. It has 276 tables, of which 46 contain geometries. Some of you might ask, why are there so many tables? One reason for this is that the geometry model is a bit different, the one that Esri uses. So the GML can have like multiple geometries in one feature type, but in the feature in the geodatabase, you have to have like one feature for each geometry type. The other reason is that it's a relational model, and the UML model is an object-oriented model, so you have to have relational tables whenever you have multiplicities, like multiple names for different features or things like that. But I will show that in the example later. I think then it will become very clear, so it's nothing that's difficult or somehow complex. It's actually sometimes even more easy than writing GML or something like that. So, okay. Yeah, the process that we use to fill this target geodatabase is so-called ETL process. I mean, Dean already explained quite a lot about spatial ETL, so it always consists of 3 main steps. In the beginning, you have to, of course, you have to get your source data, the data that you want to transform to Inspire into FME. So first step is to extract the source data. Then in the end, the target is, of course, to load it into the Inspire geodatabase. And before you can do that, you have to transform your source schema to the target schema. And during this process, you might also want to fusion data sets, because it's not always the case that all the data comes from one data source. There might be different databases, even non-spatial data, and different things that you have to use to create your Inspire target data set. On the way there, you can also do like quality controls. You can collect data about the quality that you can also put in the metadata. You can detect conflicts, or you can check the topology of the data. So there's a lot of different things that are possible. It's a very flexible solution. I mean, you still have all the power that you have from FME. So, yeah, and of course, once you defined this process, it's also very easy to have to use this process for updates. So usually it's only a very little changes that you have to do the process to also use the same process that you used for the initial filling of the database to also use it for updates. Okay, so now I just show the steps again a little bit more detailed. So here you see just a little data set that could be your source data set. And in this case, it's some administrative units and NUTS regions. And the format in this case is a MDB. Could be any other format as well. So then you have the attributes and the different data types. So the first step that you do when you harmonize this data with FME is you create a reader and load the feature type from your source data into FME. And I mean, those of you who know FME know that it's quite an easy process. You just say @reader and put in your feature, source features. You find all the attributes and data types inside FME and can start manipulating them. Yeah, same thing has to happen with a destination schema. In this case, this is an Inspire geodatabase from Esri. So it already has all the attributes and the fields that are required for creating Inspire compliant data sets. Process is again the same. You just import it to FME. It's just a few steps and then you are there. So, and the last step to load it into the geodatabase is just executing the workbench basically. So the only step that is missing is a schema mapping. And that's what you can use the ISP for. So we have some steps or some things in the Inspire solution packs that help you to come to this target faster than without. So one of these things that are quite helpful are the template workspaces. So for each of the Annex themes, we created, and even for some of Annex 2 and 3, we already created the Inspire templates that already contain custom-made transformers, which help you during this mapping process. So when you put in your source data, you only have to do some individual mappings that are special to your source data, but a lot of the things that Inspire requires and that are required, for example, for all the different feature classes like the IDs, the namespaces, the information about lifespan, and these kind of things are already integrated with transformers into the Inspire solution pack. So that means a part of the mapping still has to be done individually, so it has to of course, cover all the individual specialities of your source data. But there's already a big part of the work done so that you can, where you only have to fill out like a form where the transformers already ask you all the questions, and you put in the right information and then you start. And now I would like to show you how this works with a small example. I will just map a shapefile with administrative units from Germany to Inspire compliant geodatabase. So this is a starting point. I just opened empty FME and will now open the template. So if you have the Inspire Solution Pack installed, you have a category under Install Templates where you find the templates for all the Annex 1 themes. So I said I'm going to map administrative units. Okay, and this is a template. Find the predefined transformers. What I forgot to mention is that you also have context-sensitive help. So that means for all the transformers, you also get a description what the attributes they are mapping or what the actual fields they are doing mean with all the information from the data specifications as well. Okay, so let's get in the source data. There are also some notes that guide you through the process, but I will tell you what I have to do, so I don't think we need them, and it's easier. Okay, I said I want to read a shapefile. I mean, I think Dean already showed you that FME can read like 300 different formats, so if it would be any other format or database, would be no problem as well. But for this simple example, I'm just going to read a shapefile. Just have to point it to the right source data set. Okay. Okay, and what FME is doing now is it's basically reading this file and also reading the schema. So we see now here that we already have the attributes from the file. Or maybe this is a bit small. So we have like 6 attributes, a few names. Maybe it's also good to have a look at the file, so I can use a visualizer to do that. Okay, it only allows me to run the process if I have provided all the information it needs. Actually, in this case, the only thing I have to provide to the template is a destination data set. In this case, it's a file geodatabase that already contains the Inspire compliant model. Okay, here you see it's just some administrative units from Germany. It's not all the administrative units at all levels, because that would be quite a big data set. So it's mainly some federal states, and in this area of North Rhine-Westphalia, I also have some of the lower levels included. And yeah, maybe one word about the attributes. So you see that there's an attribute called amtlich. This is something like kind of a national code that like defines all the uniquely defines all administrative units in Germany. Then we have an ID, we have a level where we can see at what level this administrative unit is located, and then we have a number of different names in different languages, like DE for Germany, or a name and for the English name. Okay. So usually the first step when working with a template is to find the right target table. In this case, it's the administrative unit because I'm going to map the polygon data. I connect this with the first line of the template, and then basically what I do is just go through the line of transformers that it's connected. So I just see that whenever there's a transformer that has a red exclamation mark, it means that there's some information missing in this transformer. So what I do is just go through the transformers and basically make the red exclamation marks go away. So first thing is the identifier setter. So this transformer is basically there to provide the identifier that Inspire requires to uniquely identify each feature that I'm going to publish to Inspire. This has basically three different parts: the namespace, the local identifier, and the version ID. So in this case, I will just make up a namespace because later on it would have to be registered in a registry for the namespaces, but at the moment I think it doesn't exist at the moment, so I will just make up a namespace for this one. So I just say it's DE OSM because it comes from OpenStreetMap, and I call it maybe administrative units. So more or less makes sense or not. Okay, then I have to provide the local identifier. I have already a source attribute that's called ID, and I don't see any reason why I shouldn't take this as an identifier to uniquely identify this feature. And then the next question is how do I want to deal with the version ID? I could now also use the source value if I had one, for example, a date when this data set was produced or something like that. But in this case, I don't have it, and I will give a void reason. It's something that Inspire uses quite a lot whenever there's an attribute that is is mandatory but might not exist in the source data set. Then you can give a void reason value and say, okay, this is unpopulated. I don't put it in my data set. I do the same for the lifespan. So the lifespan says when this data set was inserted, or when this object was inserted into the spatial data set. In this case, I don't have this information, so I will also put it void. Then I have two transformers that are already fine. They are there for the code lists. Inspire makes quite a big use of code lists, for example, for the national levels or the country codes. And for each of these code lists, you need to provide a URL where you can find a GML dictionary that lists the allowed values. And this is already included in the Inspire solution pack. So that we use parameters where you can specify these code lists. At the moment, there's a test service running at Interactive Instruments that we use, and this is included here. But for the moment, we don't need to worry about this. Okay, the next transformer is the country. Again, I have two choices. If I have a source attribute that already contains information about the country, I would pick this one, but I don't have this information, so I select the value from the list. My data is all from Germany, so I take the DE for Germany. Okay. Then we have the national level. Again, I could take it from the list, but in this case it doesn't make sense because I have different national levels that are mixed in my data set. So I could also say choose intro attribute because I have an attribute that has this information. It's called level, and use this one. I mean, you saw in my source data that this attribute was only containing numbers like 1, 2, 3, 4 for the different levels. And Inspire is using a code list, so this is not 100% right, and I will have to do some changes with this later, or I can do it now. Yeah, why not? So I will have to map the values from the source data to the values that Inspire requires. This happens quite often. I mean, whenever you have the code lists, it's most of the times the source data will use a slightly different approach for the code list than the Inspire target model. So But like Dean already showed, FME provides a lot of different ways to handle these kind of harmonization issues. Just put in the so-called attribute value mapper and say that I want to map the values from my level to the Inspire target attribute. So this is called national level. And so now I would have to start to type in all the values manually, but the Inspire solution pack also comes with a number of lists where you have predefined CSV files so that you can import this information to FME and you don't have to type it in manually. Just have to point it to the right place. So here you see all the code lists, or all the values of code lists that are used in Inspire. You can also find it from the start menu if you have the Inspire solution pack installed, so you don't have to remember this path by heart, of course. It's all linked from the start menu, where you also find the tutorial and other things. Okay, but to continue with the mapping, I will now import the values for the national levels. So administrative unit national level is the name of the attribute. Okay, I can quick check the parameters. I don't have file names. I already see a preview here, so I have the values of the code list for the national level listed here. I will now import it to my attribute value mapper. Shows me that it found 6 entries, so now I have them in my mapper. And in my source data, I said I only have like 1, 2, 3, 4, 5, 6. I mean, I could also have specified this mapping already in the CSV file, then I would not have to put it in the attribute value mapper. If you have like very big lists, I know that there are some really long and big code lists, for example, for habitats or for protection for protected sites, then it might make sense to specify this mapping outside of FME in an Excel list or in a CSV file beforehand. Okay. Then the last transformer here is an attribute copier. That's kind of a summary transformer that shows you all the attributes that you have to provide for administrative units if you really want to put in all values for all fields in the Inspire geodatabase. So there's still some red. Most of them are void values because you either, in the implementation of the geodatabase, it's either you provide the value or you put a value in the underscore void named field. So basically, I could now go through this list and put in void values for all the values here, but I think since we don't have so much time, I will skip that. So I will just take this transformer out. So maybe in the end my data set is not 100% perfect, but it still work. Okay, then we have the names. You see that we have 3 names, and this goes into another table in the geodatabase. So we have a related table. Maybe I show 1 or 2 slides why we need additional tables when there's a multiplicity higher than 1. So whenever, I mean, the UML model specifies multiplicities, it's no problem to put this into GML or XML based structure because you can just have the element n times. It's no problem at all. But if you want to put this in a database, you get a problem because you cannot just dynamically add new fields in the table. So the solution for this is to have a relational table. So in the end, you end up with one main table where you have like the geometry and all the information that only occurs once, but for all the fields that have a multiplicity that is higher than 1, you put it in an additional table, and that then relates back to the original table so that you know or the name Münster spelled with an Ü and the name Münster with UE both point to the same object. Sometimes you even have end-to-end relations. I'm not sure if I will have enough time to cover this also in my workspace, but then the solution for this is that it's just put into an additional mapping table so that you can have the relation that is represented by these arrows in a table. So it basically means, for example, between an administrative unit and a boundary, you can have each boundary has at least two administrative units, and also the other way around. Each administrative unit can have several administrative boundaries that are the border of this unit. So this relation is put into an additional table. Okay, go back to the mapping. And inside the geodatabase model, this relation is established by a field called RID. So what I have to do is I have to put the IFC ID of the original table into this RID field to point to the original feature class. I use the attribute renamer for that. So I take the data flow from the main object table here, and I rename the IFC ID to RID. And what you see immediately after I connected it, that the RID becomes green, so it means that there's some information going into this attribute in this feature. Next thing that I have to provide is the names. One thing you can see is when you work with FME, it's always good to have a big screen. So I'll just make some room here. Still end up with the same number of features, and I have 3 names for each object, so I should end up with 3 times as many. That's why I have to go in parallel ways, and this will make FME like triple the number of objects. But you will see as soon as I execute the workspace, it will become quite clear. So in this case, I will the English name, do the same with the Okay, name is also. Now I will execute this workspace. I can already go to the. I'm not sure if I already put some data into the target table, so I will set FME to truncate the table first to make sure that we don't see existing or data from the last run of this process. But I want to make sure that you really see the data that we just mapped, so I will rerun the workspace. Okay, and what you see here in the summary is that we have now 99 administrative units, but we wrote 297, so it's like 3 times as many administrative unit names because we have 3 for each. So this is the way the relation works. And This is a target geodatabase for ArcGIS for Inspire. Yeah, and here we find the data. I mean, it's not so much to see in here. We just see that we have the local ID, we have the namespace. Oh, I saw that I forgot to map the national code. I can do that now, but I think it's clear how the process works, how this this can be used to define a mapping from any source data model to the Inspire geodatabase. Okay. But of course, this is not the only part. I mean, whenever I do schema harmonizations together with customers, usually you cannot just sit there and open FME and say, okay, tell me about your data, and we'll map it together. Usually there's some work that has to be done in advance. So we have to define the semantic map in a way so that somebody who knows FME can really has a formal or has at least a document that he can use to specify this mapping, and also a document that helps to understand the mapping maybe in half a year or in a year later, or that you can use to find errors in the mapping and things like that. So another thing that we deliver with the Inspire Solution Pack are these XML tables where you have a complete description of the target geodatabase model, together with a description and also with a relation to the Inspire attribute, how it is called in the UML, because very often in Inspire, if you look at the UML, for example, at the identifier, there's just the field called identifier. But if you want to put this into a database, you see that it actually consists of three parts. So you have a namespace for the ID, you have the version, and you have the local ID. So in this document, you have really all the fields that you actually need to deliver into or that you have to put in the database. And then then you provide kind of an operation that you use that should be used in FME. So this can be some quite easy description, like for example, set a value like DE OSM, like we did in the example for the workspace. I mean, can open the table for administrative units. So if we would do this for the data that we just mapped, we could, for example, say the operation is just set value for, set value, and then since it was in Germany, we say DE, or for the lifespan, we just said, we put a void value, so we can say set void. Or if we have a source attribute, I mean, for example, what did we take from the source data set? For example, the national level, so we say use mapping table. On level, and okay, this comes from the source, this and that source file, or this and that source data set, and this feature and this attribute, and then there's also some fields that we use to document if we already have this part done in the FME workbench process, and also a field for comments, and this is quite useful when you define the mapping together or when we define the mapping together with our customers, because you cannot always sit together. This is also something that you can just send somebody by email and then discuss in a telephone conference or something like that. So we made quite good experiences with that. Okay. Yeah, that's more or less the example that I wanted to show. Yeah, here's just an overview of data harmonization projects that we did in the last few months. The main focus, or here's listed by the annex themes. So what you see, maybe there's a lot of things, or at least we had a lot of activities with protected sites. But what's maybe also interesting, we already had some projects with annex 2 and 3 themes. Yeah, I think Yeah, what I didn't show now is because I don't have a very strong internet connection, is how to publish this data set to ArcGIS for Inspire. But I think everybody saw Roberto's workshop yesterday, for example, knows that, or you can come to the booth and I can show you a video there, but I think since we don't have that much time, we'll skip the publishing part now. Just want to add a few words about the data harmonization using FME Server. So the workspace that I just defined can of course also be used on FME Server. So FME Server is basically the server counterpart of the FME desktop that I was using. It means that you can upload a workbench there, and then users or customers can for example upload data set there and trigger the execution of the workbench remotely, so that FME Server is kind of a data distribution and data transformation platform on the web. So basically somebody could upload their Inspire source data to FME Server, then it would be transformed in FME Server, and the outcome would directly go into the Inspire target geodatabase and then published to the European SDI, or to the ArcGIS for Inspire instance that is running there. Okay, I think I'm through with my slides, so I would hand over back to Dean to show some Inspire data consuming examples.
Okay. Thank you, Søren, for that. That was very good.